Hello, I'm Seema and welcome to part 5 of the topic Acids and Bases in Organic Chemistry. In this video, we are going to carry on with our discussion of the use of the mnemonic CARIO in order to compare the acidic and basic strengths of acids and their conjugate bases. Today, in this video, we'll be discussing the fourth step, that is I in CARIO. C-A-R we have already done, and I stands for induction. Let us just revise let me remind you what the first steps were. When you want to judge or compare the acidic strength, the first thing that we compare is the charge on each conjugate base. The next step is to compare the atoms which bear that charge. If the charges are the same, then we move to the atom which bears the charge and we compare those atoms. If those are atoms of different elements, there is a possibility to compare them. But if you cannot do that also, then we move to the next step, that is resonance. Sometimes you cannot even judge on the basis of resonance. Then in that case, we move on to the next step, that is induction. And induction by itself also is a factor that may influence the acidic strength or the basic strength of acids and bases. But before we come to this, I would like to just remind you of what resonance is and how resonance is different from induction. If you look at this COO negative, the carbonyl group, the acidic group, the CO, the lone pair of electrons here on the oxygen, they may move towards this CO bond and form a bond here. And the electrons, as a result of which this carbon would have 5 bonds. There is a proper delocalization, movement of electrons. So when these electrons move here to form a bond and carbon has 5 bonds which are not allowed, one of these bonds, that is the pi electrons, the bonds of the second bond, they break, and those 2 electrons of the second bond, the pi electrons, they move towards this oxygen. As a result of which, what happens? When 2 electrons go here, the negative charge is lost, it moves towards the center. And when 2 electrons move up here simultaneously, in order to accommodate these 2 electrons, the negative charge now moves to oxygen. So in the 2 resonating structures, the negative charge shuffles between the 2 oxygens and the electrons are moving from their position. Therefore, resonance is a complete transfer of electrons. It's a movement of electrons. On the other hand, induction is only an effect. It is not a complete movement of electrons. I'll just show you. If you have HF, the difference between the electronegativities of hydrogen and fluoride, if there's a bond between them, the fluorine is highly electronegative while hydrogen is electropositive. Now what happens as a result of this? Due to being highly electronegative, fluorine has a tendency to pull the shared pair of electrons towards itself. So this difference in electronegativity, it imparts a kind of effect on the adjacent atom. Since fluorine is more electronegative, this shared pair of electrons is not shared equally between the 2 atoms. The shared pair of electrons moves slightly towards fluorine. And when it moves slightly towards fluorine, it imparts a partial negative charge to fluorine, while as a result of that loss of the electron a little away from hydrogen, hydrogen acquires a partial positive charge. Now this acquiring of partial negative, why do we call it partial? Because there's not a complete transfer of electrons. Fluorine has not snatched the electrons to form the ion. It is just in a covalent bond, and since it is more electronegative, the pair of electrons is leaning a little more towards fluorine and less towards hydrogen, thereby imparting only partial charges to both the atoms. Now this imparting of charges has an effect on the molecule as a whole. Now, as I told you, that electrons, when a conjugate base is formed, a proton is lost and the base has a negative charge. I would like you to assume that electrons are some kind of sacks of there are some kind of heavy sacks that you have to lift. It's a weight that you have to lift. And this group which is acting, or the atom which is losing which is gaining the electrons and acquiring the negative charge, let us assume it is you, right? It's you, and you have, your task is to lift that weight and lift those sacks, the pair of electrons, that one electron which you gained from hydrogen when it left as a proton. You have to lift that sack, and that sack is heavy. It's not easy to lift it. So you are doing the task of lifting a sack, and a sack of, let us say, sand, and it is heavy. It's not an easy task, and you're trying to hold on to it. It would help if you were more electronegative, if you really loved the sack, and you would happily do it. But if you did not like the sack much, you would not lift it with that happiness, and maybe you're not strong enough. So if you're strong enough, lifting the sack is easy for you. But if you're not that strong, you may not be able to lift the sack that strongly. So that is how electronegative was the atom which itself was holding the sack. But here we are not focusing on that. We are focusing on this part which already has the negative charge, and what is it adjacent to? Now you are lifting a sack, and by your side is a friend. Now the friend, on one day you have one friend, and on another day you have another friend. On one day you had a friend which was the ethyl group, and on another day you had this fluoroethyl, right? The fluorine is on the adjacent carbon. Now one of these friends is such that fluorine is electronegative, is electron loving. It loves the sack of sand that you are lifting. It loves the sack of sand that you are lifting. So when you are holding the sack with a little bit of difficulty, what does fluorine do? Fluorine helps you. Hey, don't drop that sack. Come, I'll help you. It does not take away the sack from you, but it's helping you to hold on to the sack. So it says, oh, we'll keep it. We're not going to let it go. Let us hold it. Let's keep the sack because it's nice. So an element which is electron loving has a tendency to, has an effect on those electrons. And what is that effect? That it is attracting those electrons. It is not directly lifting the electrons. There is no movement of electrons. But the fluorine present here attracts these electrons, and as a result does not allow this ion to lose those electrons. Lose the electrons to do what? To reform the carboxylic acid by combining with hydrogen ion. It does not allow it to go and combine with the hydrogen ion again, because it's making it stable. It says, okay, if you can't lift the sack, I'm helping you out. So it is an added strength. It is making the ion stable, right? This is inductive effect. The effect of an atom or a group which is causing the negative charge to be stable on the base. The negative charge to be stabilized. On the other hand, this is another friend. You know, the next day you were again lifting the sack of sand, but this time you did not have the same friend, the fluoride. You had the ethyl group next to you. And the ethyl group, on the other hand, is a little indifferent towards sacks of sand. He doesn't like sand as much. So while you are lifting that sack of sand, ethyl group, instead of helping you lift the sack of sand, it has a tendency to lean over you. Instead of helping you lift that weight, it's leaning over you and making it even more difficult for you to hold on to that sack of sand. So what would your tendency be? Your tendency would be to again react with hydrogen, give it back its sack of sand. Oh, you gave me that sack of sand, I don't want it. You just keep it with you because this guy is not even helping me hold on to it. Right? So the ethyl group also had an inductive effect, but the inductive effect was opposite. So inductive effect is only an effect that is induced by the neighbors of the atom which bears the, or atom or the group that bears the charge. And this, it may have both positive and negative effects. So inductive effect is divided into two types, or we would say it is of two types, the plus I effect and the minus I effect. Now since it is an effect, the addition effect and the subtraction effect we can call it. The addition inductive plus I and the minus I effect. What would plus I effect be? Plus I effect is a group that adds electrons to the, or which is adding electrons to the atom which already has the charge. So it is pushing electrons away. It is adding electrons to the other group. So that is plus I effect. And minus I effect is a group that has a tendency to pull the electrons towards itself. What effect is it causing to the charged ion? It is causing the charged ion to lose or to diminish its load or to reduce its load by taking away electrons. So we say those groups which show plus I effect are electron donating groups, and those groups which pull the electron and help in lifting the load, they are known as electron withdrawing groups. They are withdrawing, they are pulling the electrons towards themselves. So now if you take a look here, in these two examples, this one is fluorine. It is pulling the electrons towards itself. So it would be an electron withdrawing group. And CH3CH2 would be an electron donating group. It would be a group that is pushing. I told you it leans over you. Instead of helping you with a sack of sand, it's rather leaning over you. It's increasing your weight. So ethyl group would show plus I effect and the fluoroethyl would show minus I effect. What happens as a result of this effect to the acidic strength or the basic strength? Now I have written the conjugate bases for you here. The conjugate bases of both the fluorocarboxylic acid and ethanoic acid. Both of these are given here. Now this one is an electron withdrawing group. It pulls this electron towards itself, and when it pulls it, it makes the ion, that is the negative ion, the conjugate base, stable. It makes the charge stable, or rather it reduces the charge because it's sharing it a little. By pulling it towards itself, it's helping by not letting the charge move out, by not letting this ion lose the electron that it had gained. So this one would be a more stable conjugate base. This is a stable conjugate base. And this one, on the other hand, due to the ethyl group pushing the electrons rather than helping out, this is the unstable conjugate base. And since this is the unstable base, this acid, according to stability, this is a weaker acid. And this is the stronger acid. When we say it is a stable conjugate base, it means it is stable and it is weak. And when we say it is unstable, it's a stronger base. This is a stronger base. And a stronger conjugate base comes from a weaker acid. This we've already done in the previous videos. So did you see what was the effect of what was inductive effect and how it affects the acidic strength or the basic strength of the acids and bases? Let me take one more example of the plus I and minus I effect. Here you notice again it is the COO negative and this is CH2COO. Oh, I would also like to point out, if you look at the charge, that is the charge, both of them have a single negative charge. The atom bearing the charge is O in both the cases. And if you look at the third step, that is resonance, both of these show the same resonance too. So if you really look at the first three steps, you would not be able to judge which one is a stronger acid or which one is a weaker acid. But when we look at it closely now, we notice that we can use induction to separate these two compounds. In this case, you have the methyl group attached to the carboxylic acid group. And here you have the chloromethyl group. A chlorine is attached, and chlorine is electronegative. It will have the same effect that fluorine had. So chlorine is much more electronegative than the hydrogens or the carbon here. So this chlorine will have the tendency to help out with the sac of sand, and therefore it will make the ion stable due to -I effect. It would be electron withdrawing, it would pull the electrons towards itself and make the ion stable. That is, it would not let it lose that electron. But here the methyl group does not have that effect, rather it pushes the electrons towards oxygen, and because in comparison this will not be stabilized by gaining electrons. So, and it already forms 4 bonds. Its octet is complete. There is no need for it really, and the electronegativity difference is not there between the two seeds. So this lone pair of electrons is not helped by the hydrogens or the carbon. And that's why this is an electron donating group and this is an electron withdrawing group. What does an electron withdrawing group do to the charge? It reduces the charge. How does it reduce the charge? Because when the electrons are being pulled towards the inside, the electrons are not available to move out. The site at which electrons would be lost is this oxygen. So when inductive effect takes place, the presence of an electron withdrawing group reduces the charge, but the presence of an electron donating group increases the charge on the oxygen. Why? Because methyl, instead of pulling the electrons, is leaning, means it is rather pushing its electrons towards this oxygen, thereby increasing the negative charge. And if the charge becomes more, it increases, the species becomes less stable. It tends to react. It tends to reform the acid. That is, it combines with the hydrogen ion or the proton to give it this and give back the same acid. That is ethanoic acid in this case. This was propanoic acid, fluoropropanoic acid, and this is propanoic acid. So this would give back the ethanoic acid. So we find that the methyl group acted as the electron donating group, and the chloromethyl group acted as the electron withdrawing group here. And inductive effect resulted in making this species more stable, and since it is more stable, it is a weaker base and this is a stronger base. So if it is more stable, it means the acid is a stronger acid, and this one, the acid, if you put an H here, this would be the weaker acid, and put an H here, this would be the stronger acid. So this was about the inductive effect. Inductive effect can increase or decrease. It propagates. Inductive effect is an influence. It is either attracting the electrons towards itself, or it is pushing, the group is pushing electrons away from itself. But this is not limited to the atom which is right next to the charged ion, that is the charged atom. This effect is carried on to its neighbors too. It spreads to the entire molecule. Let us take this example and see how it affects. This is the ethyl group, and this is the methyl group which is attached to the oxygen. And if we see, I've written only the conjugate bases now. As we know that if I put an H positive, that is, this would be ethanol and this is methanol. These would be the acids from which the conjugate bases have been made. And I'm going to compare the conjugate bases to understand the acids too. Methyl group. Now, out of oxygen and carbon, carbon is more electropositive and oxygen is more electronegative. So, although oxygen is holding that sac of sand and the electron with itself, it still has a tendency to pull the electrons of carbon towards itself because carbon is not so strong. So what happens as a result of this presence of this methyl group, the methyl group pushes its electrons towards oxygen, and oxygen acquires the partial negative charge and carbon has this partial positive charge. In this molecule now, the same thing happens. The carbon which is adjacent to the oxygen will acquire a partial positive charge and the oxygen acquires a partial negative charge. But as a result of this carbon acquiring a positive charge, because its electrons have moved slightly towards oxygen, the carbon itself is positive. That is, it is partially deficient in electrons. And how does that affect? It has a carbon next to it and both the carbons have the same electronegativity, but the loss of those electrons, the partial loss of the electrons, it puts the burden on carbon to be positive, and this becomes more electropositive in comparison, it becomes more electronegative in comparison to this carbon. By losing the electrons, it is now deficient in electrons. So this carbon partially pushes its electrons towards the next carbon. And thereby, this carbon also acquires a positive charge. Although this is diminished, it is not as strong as the positive charge on this. This is a still lesser. It is even more less. And it's very, very partial. But it does acquire a positive charge. And if we had another carbon in the chain, it would have a triple delta positive charge. And this effect would have carried over. But as a result of this effect, what happens to the entire group? This entire group, now this methyl is pushing the electron towards oxygen and making this entire ion unstable, a little unstable. But when you have two of these methyl groups, one methyl group here and the next group is here, the two carbons, and both of them together are pushing electrons away from themselves and towards oxygen, the sum of their effects is greater than the effect of this single methyl group. So on the whole, this group has a greater plus I effect than this methyl group. And as a result of this, this ion becomes even lesser stable than this one. So the corresponding acid, this one would be a stronger acid, that is methanol would be a stronger acid compared to ethanol. Ethanol would be a weaker acid because the plus I effect of the ethyl group is more than the plus I effect of the methyl group. Right? So now, after having understood this, let us see what are the factors which affect the this inductive effect. The first factor that affects inductive effect is electronegativity. The effect itself has risen due to the electronegativity difference of atoms which are bound together. So if you have a more electronegative atom, it would show a stronger, if the electronegativity difference is greater, which means the more electronegative an atom is, the stronger would be its minus I effect. So if you take these three molecules, the conjugate bases now, this is 1, 2, 3. This is propanoic acid, fluoropropanoic acid, chloropropanoic acid, and bromopropanoic acid. So now tell me, which one out of these do you think is most electronegative? If we move from left to right in the periodic table, we find that the electronegativity increases. And fluorine, and if you move from top to bottom, we find the electronegativity decreases. And fluorine, chlorine and bromine belong to the same group, that is the 17th group. So out of these, fluorine is the most electronegative. Therefore, it would have the highest minus I effect. This would have lesser than this, and this would be still lesser. The one which has highest minus I effect. Minus I effect means it is pulling the electrons towards itself. If it is pulling the electrons towards itself, it is making it more stable. This would be the most stable ion. And this would be the least stable. Do you understand? Here we were discussing plus I effect. So the effect was opposite. But in this example, the fluorine, which is electron withdrawing group, it will make the negative charge diminished, or rather it would make it more stable by holding on to the sack of sand, and therefore this would make it most stable. If this is most stable, this is the most acidic. Right? Because the product, which is the conjugate base, is most stable, it would not like to reform the acid. And since this is the least stable, this would be the most basic, this would be the least acidic. And the base, of course, if this is least stable, it is the most basic. And if it is the most stable, this itself is the least basic. Right? So we find that electronegativity of the species which is present in the neighborhood, that is the first factor which affects the inductive effect. Then it's not just the electronegativity difference. How much of it is present? Is it constant? If you have the same group just once, and if you have the same group twice or thrice in the neighborhood, automatically, whether it's a plus I effect or a minus I effect, the abundance of those groups would also affect the inductive effect. For example, this is ethanol, and if you remove the hydrogen, these are the conjugate bases, this would be ethoxide. So here we find that these groups are CH2, CH3. And here it is isopropyl alcohol. From isopropyl alcohol, this is a CH3 group, this is a CH3 group. This is a CH3 and a CH2. There is no branch here. And here you have CH3, 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 3 methyl groups. Do you see? Now, out of these, which one do you think would have the maximum plus I effect? The plus I effect of these two methyl groups which are right next to oxygen, or would the plus I effect be more if this methyl group is away from it? Obviously, this would have the least effect, least plus I effect. This would have more, and since there are 3 methyl groups, this would have the most plus I effect. If it has plus I effect, this would be the most unstable conjugate base, and this is the most stable conjugate base. If this is the most stable conjugate base, it means it is the most acidic. Out of the acid would be the most acidic, and this would be the least acidic if we take its acid. Now we have one more example here to compare the same thing, that is the concentration. This is the acetate ion, this is chloroacetate, this is dichloro, and this is trichloro. It's basically the same factor that I'm bringing into your attention. Here, this is just the acetate ion. This has one chlorine, which means this was only the methyl group. Here you have chloromethane. So chlorine has a tendency to pull the electrons. This is not showing minus I effect. It is rather showing plus I effect. This chlorine is showing minus I effect. There are 2 chloros, so the minus I effect here would be even more. And there are 3 chlorines here, so the minus I effect will be most in the last compound, in the trichloro ion. So if this is having maximum effect, it is minus I. This was plus I again. This is minus I. The chlorine is pulling the electrons towards itself. Therefore, it is stabilizing the charge. So this would be the most stable. So this is the most acidic, and this is the least stable. And therefore, this is the least acidic in this sequence. Most stable is this one. So this is most acidic. This is least stable. So this is least acidic. So we can say acid strength is increasing in this direction. Now the second factor that affects inductive effect is the proximity of the group to the acidic group. I've written the pKa values of these 4 acids. And if you see, this one is butanoic acid. Here, these 3 are chlorobutanoic acids, but the chlorine is attached to different carbon atoms in all of these. Now let us see what do we understand about their acidic character. The closer an electronegative atom is to the acidic group or to that lone pair of electrons, which the sac of sand, the greater is since it is closer, it's easier for it to help out with lifting the weight. So the closer a chlorine is to the carboxylic acid group, the more would it be its inductive effect or its influence. So the minus I effect of chlorine on the second carbon would be more than the minus I effect of chlorine on the third carbon, which would be more than the minus I effect of chlorine on the fourth carbon, which means the further away a group gets from the acidic group, the lesser is its influence. It is like a magnet being pulled away and away and away from a piece of nail. The further away the magnet is, the lesser would be its influence on that particle that it has to attract. It's the same thing. The person, the helper, the friend who was helping you out with lifting the sack of sand, if the further away he gets from you, the more difficult it becomes for him to help you out with the weight. So we find that if the chlorine is on the second carbon, it means this would have the maximum minus I effect because it is pulling the electrons towards itself, and the minus I effect is the maximum, which means that it is making this ion the most stable, right? If this ion is the most stable, then it means that this acid should be the most acidic. This would be most acidic, right? And the chlorine which is to the next carbon would then be lesser than this because its effect is lesser than this one but greater than this one. So this should be the next one. This should be the least acidic among these, and this compound does not have chlorine at all. Therefore, obviously it does not have the inductive effect of the negative inductive effect, although it does have plus I effect, which we will not talk of here because the minus I effect here is much stronger. Chlorine is far, far more electronegative than the carbon. So we find that as the distance of the atom, showing the inductive effect increases, its effect decreases. So we see that this would be the most acidic, and out of the chloro derivatives, this is the least acidic, and since this does not have chlorine, this is the least acidic. And we notice the same from the pKa values. This has the lowest pKa value, which means it is the strongest acid, and this has the highest pKa value, which means it is the weakest acid out of these. Right? Now let us take one more example. Look at this compound here. This is a methyl group here, and this is the carboxylic acid group, and here this is the phenyl group attached to the benzene ring attached to the carboxylic acid. Right? When you have the benzene ring attached to the carboxylic acid and you have the methyl group attached to the carboxylic acid, we know that methyl group carbon in comparison to oxygen is more electropositive. The benzene ring also has carbons and it is more electropositive. If we look at their conjugate bases of both these compounds, in both the cases we'll get a single negative charge, right? We'll get a negative here and a negative here, and the lone pairs of electrons here and the lone pairs of electrons here. And we know that both of them would show resonance. Why would they show resonance? Because this pair of electrons and the electrons here moving, so it should show resonance between the two oxygens. This should also show resonance between the two oxygens. Now, benzene also shows resonance, and you would have a tendency to expect the electrons of this oxygen to move into the ring and to participate in the conjugation and to participate in resonance in the ring. But oxygen or the carboxylic group, the electrons in the carboxylic group will not donate their electrons to the benzene ring. It's not so strong that it can pull away the electrons from the carboxylic acid group. If it was phenol, the electrons on oxygen would have been given to the benzene ring. They could have participated in resonance. But in this case, the benzene ring does not participate in resonance. The reason being that the negative charge is being shuffled between two oxygens which are far more electronegative than carbon. Even if it's a benzene ring, the electrons here are not going to go into the ring. Rather, though the conjugation or the electrons present here may have a tendency to move towards the carboxylic group, but the opposite does not happen. So usually students make this mistake of imagining that the electrons from the carboxylic oxygen would move towards the ring. So the resonance factor also does not play here because both of them have the same resonance. The negative charge is going to shuffle between the two oxygens, and now we have to compare only the methyl group and the benzene. So when we try to compare the methyl group and the benzene, it's not resonance, it is inductive effect that we have to think of. So what is it about the inductive effect that we notice? The methyl group, although it is not as electronegative as oxygen, yet it has some amount of electronegativity, right? That is why it provides stability to the carbocation. And the benzene ring, on the other hand, has 6 carbon atoms, and it also has resonance. So you can imagine whatever is the electronegativity of carbon, when you have 6 of them, there is an added effect of the electronegativity of 6 carbon atoms. Therefore, although we may consider the electronegativity of carbon to be very low, but when 6 of them are together and there is the double bonds here, the alternating double bonds, it does have a tendency to show inductive effect. And the inductive effect of the benzene ring obviously would be more in comparison to the methyl group. And since this would create a more stabilizing effect, it would have a more tendency, the electrons would not move in to participate in resonance, but the inductive effect would take place, and this would be more stable, and therefore this would be a stronger acid, OH. Right? And this would be a weaker acid. So benzenoic acid would be a stronger acid and ethanoic acid would be a weaker acid. So this was about inductive effect and how we use it to compare the acidic and basic strength of acids and bases in organic chemistry. So with this we come to the end of the 4th step. And now in the next video, we are going to discuss about the last step, that is orbitals, comparing the orbitals. If you found this video helpful, please give it a thumbs up and subscribe to my channel, recommend it to all your friends, help me spread the word about them, and please keep returning for more videos in chemistry. Thank you and bye-bye.